So let's use the range function to generate for us a few elements over here. So for I in range, like I've just told you, transfer statements, we basically transfer the control. Yeah, we either skip, continue, or we can pass a certain action. So for I in range, let's use this range. For I in range, I will use this range function and run 10. And so what I want to do, if I is equal to 3, then we want to break out of this loop. Okay, and this is the syntax. So we just break out of the loop and then we print I. Okay, and we print I. So basically how this is very, very simple, but when now you start doing big programs, then you will start seeing how this is beneficial to you. So if I is equal to 3, then we want to come out of the looping process. So how this works, just a minute. All right, I hope you can all see my screen. You can all see what I'm doing. All right. So we are here. Okay. So what essentially we are doing, this is an iterable. This generates for us a sequence of numbers, so a series of numbers, and then we are iterating through those numbers. So when we reach the third, if we get 3 in this loop, then we break, and then the loop does not continue. So for instance, if you have maybe a list of names, or you have a data and you want to pick up maybe a few, maybe there's something that you're picking up from that data. So you don't want to waste a lot of time looping over and just continuing. It consumes a lot of your compute resources, especially if it's a big chunk of data or a database that you're trying to fetch something or fork something from that particular database. So it might not be feasible. You write up codes which are optimizable, like optimized code. That means that these are codes which they are mindful about time. Time complexity is very, very key in programming. So we normally look at shortcuts. Okay. So for instance, you want if maybe you reach 7, you don't want to reach 10. If this were 100, you can imagine if this were 100 numbers, and the time this will take will be a lot. So you see, we only go through 7 times, like 1, 2, 3, 4, 5, 6, 7 times, and then we don't loop over everything. You could if this was 77, whatever you're looking for is in the 77th position, then that also applies. So it will loop for you up to 77, and then it breaks out of the loop. Okay. Yeah, I hope that's understood. And also we have the continue. What normally happens, say for instance, let's just the continue will do something at that particular loop, at that particular index. For instance, if it's 10, let's take a simple number. If it's 10, then what's going to happen when it will continue? However, for instance, you found what you're looking for at index 10, at index 7. So the looping process will continue, but what you're looking for also should be shown. So we can say once we get 7, let's maybe print something. I have found 7. Just to let you know that, okay, I've found it, or you can just say I found it. Just like that, it works. And then we can print, I think we print I out with the loop. Let me see. Yeah, so I think it works now. If so, basically what happens here, if let's say maybe if I divisible by 2 is equal to 0, then the first instance of that should be 2. And you can see it has skipped 2. It's what is happening here, it is skipping those even numbers. You can see it has skipped 2, it has skipped 6, it has skipped 8. So it's working the way we want it. So we can print maybe I and do something like this. I think so. So this is just to put it in a horizontal way, but we can print I. What did I want to do? No, we found it. So it works the way it's supposed to work. What about, because the idea is for it to continue, but those particular the elements which are affected by this expression, they don't get printed. So we are getting the target that we want, but the rest are not getting printed. The ones which are divisible by 2 are not getting printed, but the rest are getting printed. So as you can see, if it's divisible by 3, so all those numbers which are divisible by 3 will not be printed. However, those which are even now will be printed. And what other? Let me see. Let me see if I is equal to 2. What happens here? In this case, you can see we are skipping 2, but the loop continues. So it works the way we want. What happens is when you reach the number that you're looking for, you probably, let's say for instance, you are looking for a particular number or a particular element in a sequence. And so when you find that element that you're looking for, then something should be done. Maybe you want a certain code, you want something here, for instance. I have found, for instance, you can say, I have found 2. And this can be any code. You can just say, I have found 2. And if we check, we have found 2, and that can be, I have found 2. And you can see that it's now, when it hits the second index, then it prints out for us what is in that position. And then the loop continues, but whatever you found also, it shows that it's been found. Okay, I hope that makes sense. All right, so let's move out from there. Another iterable is the pass statement. So the pass statement is normally very, I explained it last time, or maybe for instance, yeah, this is just a function, adding a function that adds numbers. And you still don't want to, you're still thinking of something here. Maybe you're still thinking of something. So you still don't know what to do with whatever the logic that you want to write. So you just pass, and it will run. However, it will run. It just ensures that your code is not broken. Like let's say the password. Let's ask the password from a user input. So this is the password. Please enter the password. Password here. So we enter. I want us to use with the password. So enter the password here. So I want to create. Let me create an infinite loop. So we probably can start with the while loop here. So while true, and then, so this is a loop, you have to indent. Okay. So while true, while true password input, please enter password, and then what we do if password is equal to maybe seat, we need to do something in here. If password is equal to seat, so let's say something, maybe access granted. Access granted. And else we can say, and this will help you a lot in writing your game, the assignment that you're doing. Else you can just say print, please enter the correct password. Okay, so let's run this game and see this. Here, once we get this, because we want to use the break. So once we get the password, there's no need of consuming a lot of time. Because this could be a bank with maybe you are trying to do, like I've said, maybe it's a bank. You want just that particular name. Once you get it, then you want to go to another action. You want to do something else. So once we get this, once this user enters the right password, then we give them access, and then we break out of the loop, because we don't want to consume compute resources, which are very, very essential in programming. So what we want to do here, as you can see now here, so if we've entered an infinite loop, and every other time, is it responding? So let me just kill the kernel and then try again. Are we together? Tell me if we are together. Are we together? Let me not be speaking to myself.
Yes.
Okay.
Yes, we are.
Oh, Lewis, how are you? You managed to come. How are you, Lewis? We added you very late. We have Lewis. You came.
I'm okay.
Okay, good.
Yeah.
All right. So let me print this. So if I enter password here, so let me just enter something. So we've entered into an infinite loop, and wherever you find yourself in an infinite loop and you don't know how to come about it, you just click control. You disrupt the kernel. This is the kernel, and the way we normally do it is just control C. Yeah. So I'm back again. So let's enter. Yeah. So let's. So if we write now the correct password, this is what we get. So access granted. Okay. Essentially, what I'm trying to show you here is how you can be able to use this in writing a good program or an effective program. So please enter the password. So let's go back to the logic. So if we look at the logic here, or if we look at the logic here, so we've managed to break out of this loop. Because we have the user got the password, and we've given them something like access granted, so we break. But in the event that the user didn't get this password, then all this does not work. This particular block of code or statement doesn't work. So this works. So we jump into the else block. Okay, I hope that makes sense. All right. Any question? Let me check. What did I have for you again? Any question? We have the return statement also. However, I like using this in we have the return statement, but let me not get into that because we'll do it in function. So let me leave that out. Okay. So for the transfer statements, they are basically just those. We don't have much to talk on those ones, particular ones. So Yeah, that is that. So the major thing that I wanted us to do today is functions. Functions is my favorite area, because if that particular assignment that you're doing, if you can bundle the codes in a function, and it becomes more efficient. All right, so let me just take you. Function is just it's just a collection of codes or statements or blocks of codes that are supposed to do a certain thing, and then they run. So when you call that function, then they run. I mean, the pieces of code that are inside that function, they run. And that's the essence of a function. So if you look at my definition in here, so it says that it's in simple terms a function. Wait, a function, where is it? Can you see my screen? It's a device that groups a set of statements so they can be run more than once in a program, package, procedure invoked by name. Function also can compute a result value and let us specify parameters that serve as function inputs and may differ each time the code is run. Coding an operation as a function makes it generally useful, which we can use in a variety of contexts. More fundamentally, function are the alternative to programming by cutting. Okay, basically, we don't have to go to that theory. So let me just, so when we are writing a function, we normally have certain things, parameters that we have to define. And so when you're writing a function, one thing that you need to know is that you should not use the keywords just like in variables. So you don't use certain keywords. So you only use words which don't clash with certain words in Python. So you try to avoid that. Okay. So for instance, we normally use, when you're writing a function, we normally use this keyword. So just once more again, in a rundown, once more again, let me just give you, we've seen that a function is a collection of statements. Let me use that word, statements. Okay. They perform particular tasks, certain tasks. And what are these test statements? These statements are just codes, pieces of code that you're writing, and you want it to do something. For instance, I'll give you an example. A good example is like maybe a vending machine or an ATM. So an ATM can act like a function. If you're programming an ATM, you need to put all those parameters that will allow it to work. So an ATM takes in an input. Okay, it takes in an input and spits out something. So a function will take in. We will first of all have the definition of the function, which is the header, which is called the header, and we use the keyword, which is the def keyword. So when Python sees this, it's going to assign the name to a function, this name to a function. Okay. So for instance, when we want to add a few numbers, we need certain things. We need input. So what are you adding? You are adding maybe two numbers. So if you're adding two numbers, A plus B, you need these inputs. And these inputs are called what? These inputs are called parameters. Now be very, very careful. Be very, very attentive. These inputs are called parameters. And whatever we assign to the parameters, they're called what? Arguments. So for instance, when we assign 2, 3 to A, these are arguments. So these are called default arguments, and I'll come to that. Don't worry about now. I'm just trying to explain to you. So these are arguments. So the variable B is a parameter. Whatever is assigned to that variable B is called an argument. Okay, I hope that makes sense. And what are these generally? They are called inputs. And sometimes we can write functions with minimalistic properties. For instance, this function doesn't have anything, but it does very simple thing. Like maybe this can be just a greeting function that will just greet someone. This is just a greeting function. So in this function, we use this parenthesis. This parenthesis is where we put in what we want, the input. We insert the input, okay? So if this is a greeting function, we can just print something here. Good morning. And it's going to spit back to us the same. It will just spit back to us the same. Good morning. So this is a very basic function, but it gives you a high-level overview of what a function is. It helps in explaining to you this. So this is then we have the last part of the function, which is normally this. So this is a call. We are doing what's called a function call. So a function call is like talking to the machine that you've created. Hey, I've created you. I've made you. Now, can you do something for me? Vending machine, like maybe the ATM, for instance, an ATM. It's working now, but it cannot work until we slot in our ATM cards. And then we have to press in cancel so that it spits back. I mean, like when you slot it in, it's going to give you back something, like it give you back your cash or your balance or something. And if you like in this simple function, the action of it giving us something is what is called calling. So we are calling this function to give us something. So for us to work with this function, since we did not pass anything, we can just call it and it will tell us good morning, as you can see here. Don't worry about this none because it's not returning anything. Now this function, it does not need an input. It's just doing the work of it's a very useless function for now. So it's just printing for us the word greetings, the word good morning. Just that's what it's doing for us now. However, we can make it more likely, more lively, or more. We can make it a bit. Let's have a function that is doing something. So CB. So this function now is not a greet morning function. So now we want the sum of. We want the sum of C plus B. So we can write something like this. You don't have to do this but this is normally just for readability's sake. So now we are calling the adding we are calling the adding function. So you have to put in that name of the function, adding. So what are we adding now? Now we have C and B, but C and B needs to be something. So this is now the argument that I was talking about, because you cannot add those C and B. Those are just variables. So when we're adding C and B now, we need to give C. We need to match C with a corresponding argument, which is here. We need to match B with a corresponding argument, which is here. Okay. And now, can somebody tell me why we are getting this here? Can somebody tell me the mistake I've done? Okay, I've used a keyword. Sum is a keyword. So we can say maybe sum to avoid interfering with Python. So let's just use sums. So, and we can return this now. This is where we use the return keyword. So we can return sums now, and you can see now it's disappeared. So because we've used it correctly, it would have worked, but that's not good because it will clash with Python, because that sum is a keyword. So if we print this, it needs you can see that our function is working the way we want it. It's working the way we want it. Okay. So let's run it again. It's working the way we want it. We have 11 because 4 plus 7 is 11. Now let's go back again and explain a little bit again what's taking place. So just in case you're not getting it. Yeah, so this is the function header. this is the block of code that you want to run. And this can be anything. This can be anything that you want to write, because what a function does is that it makes your work easier. Instead of repeating code, it reduces what is called code redundancy. So instead of repeating code, you just write one function and then you call it once. And sometimes you will not even see this. You just need to know the name of the function, adding only just that. That's how frameworks work. We don't need to know a lot about what Peter has done behind the scenes. This could be me. I've worked behind the scenes. I've come up with a function that does something. So if people import this module of mine, or module is just a package is just a collection of libraries, or a collection of let's use a simple word. It's a collection of blocks of statements. So these are the blocks of statements that we are talking about. This is the header, so the blocks of statements, or whatever we want to run. And this is the function call. And so when we call this, and every other time, another person might use this function. They might not put 4 and 7. They might put something different. So any other time that they use this particular function of mine that has been created by me, it will work for them the way it was intended. It was intended for it to be adding 2 numbers. So that's how it works. Okay. So we get 31. We get 31. All right. Any question? Any question? If you're not understanding anything. These things will get a little bit complex as we go by. So that's why it's good for you to ask questions at the initial stages so that you don't get confused as time goes by. Okay. That's a very simple one. Now, there are those, what we call now the keyword arguments and their default arguments. So let me check my notes again. Functions. Okay. So let me share with you what. So as you can see in my notebook here, what I'd written here, we have positional arguments. And so for instance, we have this function. What this function does, it's the work of this function is just to print for us something about animals, or like an animal and the pet name. So what we basically want to print is just the name of that, the name of a pet, and the name of the animal type, and we can still repeat this. And so I've shown you those arguments, and those are called positional arguments, the way you see them here. And let's just redo it, and so that you can see it in practicality. Let me add another. Maybe I can just add something. Okay. This is self-explanatory. I don't have to repeat this. Okay, let's do it. There's no harm in doing it. So the first argument that we're talking about is positional argument, which I've shown you, which is C and B. And as I've explained to you, that those are their parameters, and then the value is what's called the argument. So for instance, this function, and get used to writing documentation. For instance, this function, we want just to print pet's name. So def print, so just call it, let's pet names. And like now we need, we probably need, let's use another example. Maybe we need the age of the pet and its name, okay, for those pet lovers, and its name. So these are positional arguments. So we can, let's just print something. And we do it in advance. We haven't given those names yet, but we write it so that when we are calling that function, so we call that function using the names that we want. So we can say here, of course, we normally just use string function, so our pet probably be a cat. My cat is called Harry. So we'll give it the name Harry. So we pass in the variable name here. So positional argument, we pass in the parameter name, and then we will populate this pattern. We will match it with the arguments. That probably we can call it Lucy, Harry, and whatnot. So my cat is called maybe Harry. My cat is, let's give it the age first. So we're gonna grab here the age of our cat. So this cat, my cat is old. My cat is maybe 2 years old, and it's called, and it's called, it should be an it, I think. It's called, and please somebody tell me the mistake, why we are getting an error, why we are getting that quickly. What do you think is causing that? Please, quickly, please, because of time. Why do you think we are getting this? Why are we getting that error? Please talk to me. Catherine, or Jess, you are muting.
I've seen you've mixed the kind of quotations. The initial ones were single quotes, and still inside you still used single quotes, so it's confusing.
I can't hear you. Oh, I'd muted. Okay, from my side, I'd muted. Okay, and Nick, please go ahead.
I was saying, on the quotations, we've used single quotations all through, so it's like confusing the compiler. I'm thinking maybe we use for the outside quotations, use doubles, then inside.
Okay. Somebody else? Okay, so Nick, that's correct. So yeah, so you've seen how normally, if we want to, so because we've used this one, we've not put here an escape character. Sometimes you can use an escape character if you want, but if you use it this way, then you have to change this. You have to change this and put it this way. Okay, so if we print this now, so why we are not getting any printout? And I've run it.
We didn't get to call the we didn't call the function.
Excellent. And how do we call the function?
I've seen you used to print, but can you just have it written pet names, then you have age indicated inside and the name? Is it?
Yeah.
Does that also work?
It will work.
The other time we used to print.
Yeah, it will work depending on my. Right now I'm using Jupyter Notebook. I'm using my Anaconda distribution, but if I use my Jupyter Notebook, then it will sense. But yeah, it's basically just the same thing. So we just print, and then we print. We use the same pet names, isn't it? And you see now the good thing. It tells you that, hey, I need the age of the pet and I need the name of the pet for me to run. And we had already declared that when we are defining this function, in our declaration, we've said that this function cannot run without the age or the name. So here we need maybe 12 years. And maybe the name is, since it's a string, we have to write it as a string. Harry. All right, so this is now going to run the way we want it. So my cat is 12 and it's called Harry. So we are getting none because we have not used the return keyword. Okay. In this case, this is a very simple, so we don't have to use this return keyword. Okay. Another function, maybe let's look at the other examples of functions. So maybe let's try to reverse a string def. So I want to reverse this string like I was showing in that display. I got that motivation from there. So we want to reverse this, to we call it reverse, and you cannot use it this way, this reverse, because it's a keyword. So you have to do something. So we want to reverse a string. So we will need that string. So we have to give it some sort of a parameter. So who wants to try? Who wants to try this? Let's have an interactive class, please. We started on a wrong footing, but we can make it lively. Let's have an interactive class. Who wants to try if I don't call your name? Melissa, you want to try?
Can you please repeat what you're supposed to do, the instructions?
The instruction is that write a function that reverses a string. Let me write it. Any string. So I've given you there. So you see, if I put this and if I write pass here, I will not get that error, that like showing an error. So while you're still thinking, we can do something else while you're thinking, and I could just go on and this will not disturb me. But if I leave it the way it was, then it will disturb us, or you just put this. But this only works, I think it only works in this distribution. In others, this will not work, but pass works everywhere. But you can try it anyway. So who wants to try? Catherine, Mrs. Velia? I'm going to be asking you this in the hackathon, so please pull up your socks. Amunyen, you want to try? Let me look for your names. Oh, Mr. Hacker, Brian, you want to try? How can you be left behind?
I was trying something on the previous one. The one finding apologies, or what was it? The pet name.
Oh, okay.
Yeah.
Tiffany has pasted something. Tiffany, I've seen the indexing that you've shown. Yeah. Okay. Somebody else? Anna? Elizabeth. Do I know Elizabeth? I think. Okay. We'll find out later. Ivy, you were not there last time. I don't think I saw your name. Who wants to try? Jeremiah? Susan? Okay, so let's work on it together. So we want to reverse a string. This string could be maybe, the string S that we are talking about could be anything, any string. So let's say we want to reverse this string, okay? We don't have to define it here. We will pass it at the right time. So there are so many ways, but I like making it very, very easy. Like I've told you that make it very, very easy. So this string is, let's say this is the string, and we use, I know we've not done this. We use indexing to do that. So we will use this -1, and we call this function. That is it. So we just print it. This is, we are still on function, so don't get out of the, don't think we are getting out. I'm just trying to show you how functions work, but this has just come to my mind now. So, and then we just and then we pass the string, so we can just call this string maybe sit. So our slicing is not correct, is it? Where have I made a mistake? Can somebody tell me where I've made a mistake in our slicing? Because I wanted to do negative. Is it?
We've used S as caps and on the return statement.
Or S as cap on
the S is caps, while in the method.
Yeah. Oh, by the way, this, it doesn't matter. This is just a placeholder. This, okay, let's do it that way. Oh yeah, you are correct. 100%. You're correct 100%. Okay. Let's see. Did we manage? We managed. This is very, very important for you. This indexing, when we start doing this, is a lot of fun. We managed to get that. So you see here, and if we pass in any string, any argument, it will do for us. It will get it for us. Even if we do hello, it will just, you see, that's the beauty of a function. The function, what's important is the logic. The logic that you put inside the function is very, very key. So it will give you exactly what you've put in here, because we are returning. And you can see now we don't have that none, because we are returning. And why do we use the return? Because we can pick up this and use it in our program in future. But if you print, it just dies immediately. So if you use a return, you can always get this and use it later on. So yeah, basically about that. So let's look at, let's say, for instance, I gave you a certain example, but it was out, it was not, it didn't have, we didn't use it inside a function. Like we can say, we can even use a while loop inside a function. Like, okay. Let's use some, what do we want to use here? We can write a program that does what? If it finds, just call voting. Let's call our program voting. So for someone to vote, we need to know, what do we need? Let's say we need their age. Yeah, let's say we need their age. And we need a person's name. So let's use that for now. Now we need a particular person. Let's say we don't want to make a mistake with the name. So we can use the default argument. So we can when we are defining our function, we give it a default name. So we can just say maybe Ken. Maybe let me use the names of you guys so that you don't feel. All right. So let's use, yeah. So for Melissa to vote, we need her age and we need her name. But now we are not leaving it to chance. We want the program to run. Perchance, if in future we forget to write the name, then it will just run without incurring an error. So for age, let's now you will start seeing it playing the way we want, because now we can start using the conditionals, like the if-else statements. You can use them inside. We can bundle all the things we've learned inside a function, and then we just call it once and it does it for us. So let's maybe use the things we've used before. Can I use while? Can I use while? Or let me use a for. For name, and you have let me see. Okay, let me make it very simple. Let me not make it complex. So if name is equal to if name is not equal to, okay, if name is equal to Melissa, then we can say you are allowed to vote. Print, you are allowed to vote. Else, elif name, elif, because I have two variables, so elif age. Okay, if name is equal to Melissa, you're allowed to vote. Elif name, let's make it simple, is equal to John to Emma, for example. We can print you are not allowed. You are too young. Or for instance, you are too young. Okay. So we can even say if name and age, if name or age. Let's not get into that first. So elif name, so you are too young. Else means those other conditions are not fulfilled. So that means if neither of those are in play, then we can say you are not allowed to, we can say maybe try another voting station. Try another voting station. Try another voting station. So let's see if this program runs. Even though we can make it a little better than this, but my idea is just to try and explain to you how these functions work. So what we do here, we print. So we print voting. And now, even if we don't pass the name Melissa, so we can say maybe 20, maybe 34, print 34. So let's say. So now we don't have to worry passing the name. It's like in the other cases, because already we had defined it here by default. Okay, so we can just print this and it should run. Try another voting station. So those conditions are not met. So that means, let me not get into the logic or the semantics, like the making of sense. Let me get into the how the functions are working. So what essentially has happened is we've managed to successfully use these, which we had before, we didn't put them in a function and they were working. So you can see that the function organizes our code and makes it neat. And we don't have to, later on, we don't have to rewrite this. So it reduces code redundancy. So we don't have to rewrite this. We just need to call only one line of code and it does that. And this could be 100 lines of code, this logic in here. And so it will still run as long as we know what it wants. So for instance, if you want a function that creates a widget, a window gadget, you just create that logic, you bundle it inside a function, and then you create, and then you call that function. In this case, so name, if we change the name here, what do you think will happen? Let's see. You see, it's telling us that we need to use the name Melissa. Okay. Try another because the conditions are not favorable for us. So this last block of code runs. And we can also do something here. We can use keyword arguments. I think these are default arguments. So let's try and use keyword arguments. So with keyword arguments, we don't put anything here while we are writing. So we just define them here this way, maybe 45. And maybe here we can say, let me just start. So this is gonna run for us. So if name, this is still okay, it will work. However, this is the code that will run because these are not, the name is not this one. But what if we change the name to another voting station, because these other ones, these two, are not being passed. They are being bypassed because this test has failed. So we are going to the next block. But what if we put now the name, because the function demands that it's only Jess who's supposed, elif name is equal to Jess. Let's see if this will work now. Yeah, so you see now, what's working is this other one missed the test because it's not Melissa, it's now Jess. So if the program finds Jess is available, it's been passed here, then this block runs. So we skip the first one, and this second block runs. And you can see here, you are too young. So this is the block, the what's getting printed to the user. What if, yeah, and then here now we pass Melissa. So this is, you are allowed to vote. So you can see now the first one runs and not this other one. So at the first instance there, the program cites this, so it runs. So what normally happens in a function is that when this line is hit, when the program reaches this line, it jumps to the top and checks the condition in here. If this condition is met, then this block of code starts running. So it runs starting from, it comes here first and then checks. Okay, so it checks, it gets the arguments in place, then it comes here, it confirms the arguments, it also comes here, then checks the way they're supposed to run. Okay, I hope that makes sense. Is it making sense to us? So let me see about functions, if there's anything that I wanted to add. Yeah, so function has a lot of many uses in programming, and you're going to do a lot. You're going to work with functions a lot. And let's think of another example. So for instance, let's
can't see the screen. I can't see the screen.
What about the rest? Can you guys see the screen?
On my end, I can.
Yeah,
Yes.
I can.
Yeah, so it's yours. Let me just reconnect it again. Okay, so we are back. Okay, so let's try another example. So let me think of another example here. So we had used this. So what do we want to do here? What do we want to do here? We've done the one we did for the password one. We can still also put it inside the function, like we use this while true. So we can just say def. What were we finding? I don't want to get to that guess game by the computer because it's part of the assignment, so I don't want to do that. Yeah, so that's all about functions for now. I don't want to get into scope, even though that's the next topic in doing functions. What else can I add here? Let me see an example. And maybe, and even we can add, we can just add, adding numbers again, let's just call it adding numbers. And in this case, let me see what we can do here again. Let's say we're adding yeah, let me just pass anything here. And just get some sort of manipulation. So you can just say n while true, while true. So this is going to take us into an infinite loop. While true, what we want to, while true, if n is less than or equal to, while true. So we need, do we need a counter? No, I don't need a counter here. Yeah, so let me just say, if n is less than or equal to m, then we do something. Let's return n cubed, something like that. Let's see, to work. Let's see, n times n, or n raised to power. And then we can just print this. And this is gonna cause problems, I believe. Let's see. Manipulation. Oh, manipulation is not a keyword. Let me see. So let me just here to try. So you can see this is doing something for us. So we are just, let's say this is even 2024. So that means we need to put maybe something here. False. Not possible. We can just say not possible. So that if the condition is not meeting the test, then we get something. We don't just leave the user that way. So we can just say not possible. No. So our program is not working, so we have to check, and it's like while true. Let's break this. Mm-hmm. 16. So what we just raised this to the power of we've raised this to this power. So that gives us 16 and so forth and so forth. Let me see if I change a 5. So we've entered into an infinite loop, which we don't want. Else, what if I break? We can even introduce a counter here. Maybe we can introduce a counter here. and then maybe increment the counter. Then we probably don't want this. Oh, we're still entering into an infinite loop. What if, I don't know why it's not working. Let me use another one. Let me use this one. Access password. Access. Grant access grant. So let's say what we need. Let's use age and then name again. So we can say while true. While true. So we did this out of the while loop, out of the function. So you can pack this and put it inside a function. And I've made a mistake here. So please tell me the mistake I've made already. Can somebody tell me the mistake I've made? Before I call your names.
Indentation.
Sorry?
You have to put an indentation.
Indentation, right?
Yeah.
So that's good. So we have to, it's good at least you notice that. Let's enter. Let's enter password. So, and if password is equal to something that password is equal to seat. We did it outside there. Then we need to do something again. We said print access granted. Access granted. And so we can wrap in, we can also use the else. So we can print access not granted. And we can do here while true. So I think it's further indentation because we started writing. Yeah. So we are just access. Access. So we need the age and the name because grant access grant name. Why am I getting this? Why do you think you're getting this? Age. So how can we fix this? How can we fix this? That's the analysis. Can we fix this 90? We have to tell me what we need to do. We have to replace this, isn't it? So we can say here, because we've already defined them here, so we have to replace this. So let's see if this runs. However, there's a lot we can do on this. So we've entered an infinite loop. we still so let's sort this out. Talk to me. We've entered an infinite loop. Look at it. Even if we run it, we are still entering an infinite loop.
Should we put a break after the else print below it? Should we put a break
here under this
after that? Yeah.
Under
else
here.
Yeah, after this, after the print.
So you want us to put a break here?
Yeah.
But okay, it's not correct. You know, this is the last option for we want if the password is correct, then we don't want the user to keep on, you know, entering. We want the program to go to the next level. So if you come here and you put it here, that means you want to break when already the program has stopped working. Because at this level, in this block, the program stops. Because this else is going to be printed. So if you put it here already this has been, we don't need a break here. Can someone try?
Can you try?
Say that again.
You indent the if statement, 2 tabs in, so that it is below the while loop.
You were saying the
else
statement, the else or the if.
The if statement, the if and else should be indented inside the while statement.
Okay.
Yeah.
So this way.
Yeah.
No, it's not working. True also. Somebody else? Somebody else want to?
The input for password. I don't think it has been closed at the end. And also the indentation, as Stefan had said. Oh, sorry. Yeah, the... Okay.
All right, somebody wants to try. Okay, let's print the output again so you see where we are having issues. So we've entered into an infinite loop because we'll just keep on. Because you see, I've entered even sit and we're still going on. Jeremiah, you're sleeping or cooking. Amunyin, Bonnie. Okay, Ivy, what if we put a break here? Because we have found, you know, we are assuming if this user enters this, then we don't need to go further with the program. So we need to break at some point. What do you think?
Can I try?
Yeah.
Are you able to put break after password? Input password, please. Immediately after password input, please enter password. Then I'm thinking the quotes, the one that you have kept, you have put a lot. There is a space there, so I don't know, but I'm just thinking. We try that after.
Let's start it. So let's start it because you know we refactored another code. So we might have problem with indentation.
Is the purpose of this function while you enter the right password, it should go to access granted, and if you don't, it should go to access not granted.
Yes.
Let me see. Okay. Let me try something.
Okay.
I'll get back.
Okay. Yes, you want to try? I'll call your names, all of you.
From my end, when I'm trying it, it's just working fine.
Yours is working?
Yes, from my end.
So yours is working and you're quiet. Just can you share your screen with us and explain to us how you've done it? Okay, first of all, let me finish here, then you share with us yours. Okay, so let me rewrite it because I think we missed some. So this was the, so if password, we had said if password is equal to seat, then we want to print access granted. Access granted, okay. And else we want to say we want to print access not granted. And then while so, and then we just call that function. Yeah, so okay. Let's run it again. We see so the problem is still going to be there. Let's come out of this first. Okay. So when we enter password, access not granted. So it's working the way we want it, access not granted. Because we've entered the wrong password. And now if we enter seat, it's working correctly. Enter your password. But now it's working the way we want, but there's one thing that I'm looking for that you guys are not telling me. Somebody has raised their hand?
Can I?
Says yes, Samson.
It's Tony.
Yes. Oh, who? Tony.
Yeah.
No, Tony, I don't want you to share. Okay, I want just to share your screen.
Okay.
And explain.
Not sharing like the code.
The previous one or now?
This one, which is bringing issues.
No, I've changed it now. It's working. Or is there?
Oh.
It's working now. It's
I
working,
thought
but
it was not breaking the loop.
It's not breaking the loop. I don't want you to share about that coming out of that. But you see, okay, let me run it again, Tony. So the code runs the way we want. However, the code runs the way we want. However, we need to completely, because you see, it's like you've entered your password in a system, a certain application, but still it keeps on telling you enter your password. So we don't want that. Once you enter your password, you need to go to the next thing. So enter your password. So we've entered correctly the password. So it says access granted. However, we are still continue to say this.
Can you can you put break after the print access granted?
Yeah, so that's what I didn't want you to say. So I wanted somebody else, from the new guys to tell us that.
Sorry.
Yeah, anyway, we've hacked it. Anyway, that's the bone of contention. Let me see. Let me clear this and see if yeah. So that was the missing point. You see now, it's ended the way we want. So we are not getting that looping. Okay. Is that the way you did it?
If I may ask.
Yeah.
No.
Okay, it's working, but my question is now, why is the break coming there and not at the end? Is it not supposed to break after the program is done?
No, the break is coming here. Remember, I said that once this is a user, this is you. Let's say, for instance, who's this? Is it Nick?
Yeah.
It's Nick. So Nick, so this is you. You are entering into a certain system, and you have been granted access. So if you've been granted access, there's no need for this other part. There's no need for you to go into this other part because you have been granted access. So you don't want to go to this. It's like you are adding, I gave you this example here. I will also do it. I gave you this example for I in range 5. Let's take a shorter one. So if I is equal to 3, 4, let's say 2, then we don't want to continue. We just want to break and come out of the loop. You see? And then we print I, and then we print I out of the loop. You see? So we can make it like this. If I is equal to for I in range, yeah. So let's print this and see. This is not in this function, so I'm printing it out of this function. Let me print this. So this is what I'm trying to show so that you can relate it to when we put it inside the function. Okay, don't worry. Let's because now it's picking everything. I didn't want it to pick everything. But let me just I want to run only this other one. I only want to run this, so I just need to print this one. But already does pick the first one, so let's just finish that one. And then let's clear, and then now just run this. So we want to run the selection only. So if you run the selection, you can see now, we are not going to, we've broken out of the loop. The loop is supposed to go up to 5. But because we used this break before here, so we just break and then we print this out of the loop. We are not going inside. If we put it this one, then essentially what you're telling me is like, we still want this program to run when we've already found what we're looking for. So assume in this case, you have this in a range. This is like 1, 2, 3, 4, 5. Now you're only looking for 2. You have found 2. Why do you have to go all the way up to 5? You don't need to. Do you see the sense? Does that make sense, Nick?
Yeah, I get it now.
Yeah. For instance,
it does.
Let's say if these were 5 million, these were 5 million sequences or series of words. Why would you waste your computer's resources? That's how you should think as a programmer. So you only want the 100th time. So when I is 100, then you want to stop and do something. You see? So here, you probably want, after you've broken out of the loop, the control, then you want to do something here. Well, maybe you want to do something, write another logic that affects this particular line. That's why you are breaking. You see, or you have found the person that you're looking for. If maybe you created some script for, for tracking someone, so you have found that person, or you have found a location. For instance, somebody, you are tracking somebody, somebody has stolen your phone, and you're tracking them. So you have found this person, so you don't have to go. You don't want to waste a lot of time again looking for this person. Does that make sense to you?
Yes, it does.
Yeah, so we don't have to
Thank
come all this way. We are only coming, this only works when this is not met. This first test is not met. Yeah, this first test is not met. So let's do it again to. So if the first test is not met, so for instance, the password is DDDD, you've entered the wrong password. So it keeps on telling you access not granted, enter the right password. Now we are coming into this because the first test is not met. You see, this if is not met. So we are jumping into this. Essentially, that's how it works. I'm interested in knowing the way you just did it. Can you show us? If you didn't do it our way and you did it another way.
No, I just made a mistake somewhere, but I've seen my mistake.
Okay, so all right. So I hope that makes sense. Any question on this? Okay, so I would like to see you guys using it in that assignment, because I think I've given you some secrets over here that you can use in that assignment. And you can even put, print here, like, welcome to sit, please. Welcome to Solution Center, to sit. And you can go wild with this. You can go welcome to sit. So you can tell them, please enter, name. And name, you can say, please enter. I've not done it correctly, but I know why I've not done it correctly. Enter your name. So you can tell the user, please enter your name to make your game more fun. Like, it's up to you. I've given you the rubric for that game, so it's up to you to give me more. Enter your name. Okay, so enter your name. So you can say here password. So if name, so you can add if this person's name is a particular name. So if name is equal to Emma and password is equal to sit. Do you see how you make it now fun? So you are making your game a little bit, okay, your program, let's call it your program, whatever it is. You're making tighter because you want them to give you the name and password. So if name is Emma and password is same as it, then you can give them access. You see, and you can now check how does this behave. But this might not behave the way we want it because of something that I will not tell you. I don't want to give you clues, more clues, but we can run it. So let's see. Access grant, also let's run it again. So welcome to sit, enter your name. So we can say Ken. Enter your password. So I'm giving you more tips here. So let's say sit now. Access not granted. Yeah, because I've changed the logic. So we need the name to be Emma and the password to be sit. So this has to match. So when this matches, so let's assume, but now I'm giving you clues. Should we go on or not? Enter your password. So we have to break out of this if we want to do it correctly, but clear console. Yeah, so I've given you enough hints here, so I don't want to go further on that because I'll be breaking the rules of the game. However, I would like you to add another thing here in your game. So if name, you can say if and enter your name. So while true, if password and name is equal to this one, print access granted. For instance, here, access granted, then you want to tell them, like, you get access granted Emma. Or you can just say, let me note, hi Emma, access hi. And you know what we normally do, hi Emma, access granted, and we do what? Formatting, and that will work. And of course, yeah, hi Emma, but of course you have to put that formatting because otherwise it will not work because of you have not used formatting. Hi Emma, access granted. And you can also say welcome name to set.